Okay, international statistics 2022 January. Are we ready? Make sure that you have a scientific calculator and that you also have the Z tables at hand, okay? Make sure you got your Z tables, the formula sheet. It's going to be really helpful. Here we go. Question number 1. Okay, now it's really important that we do actually spend the time to read the question. Okay, it's something sometimes I skip over, but it's probably one of the most important parts of stats is reading everything, getting all the information, knowing exactly what's going on. So a factory produces shoes. A quality control inspector at the factory checks a sample of 120 shoes. Okay, so what does that mean that our total should be? Yeah, so we know, so this is key information, so we can literally write that down. So the total is 120. Of each of 3 types of defect, the Venn diagram represents the inspector's result. A represents the event that a shoe has defect stitching. Okay, so A is for what? Stitching. B is colouring. C is soles. Okay. One of the shoes in the sample is selected at random. Find the probability that it does not have defective soles. Okay, so it's really good probably now to know, right, so A is stitching. So what do you think I'm going to write? Stitching. What's B? Colouring. And then what's C? Soles. Yeah, we're looking into your soles. Okay, so find the probability that it does not have defective soles. What does it mean if it does not have defective soles? Okay, if it doesn't have defective soles, it's anything but C. It's basically the probability of C dash. Okay, so where is C dash? 90193. Yeah? So this is all not C. So what is 90193? 9 plus 1 is 10. Plus 93? 103. Now what was the total? Over 120. Perfect. Nice and easy. 1 mark. Probably the easiest mark on the paper. Now, find the probability of A intersection B intersection C dash. Now, the best way I love to do this, you know Miss loves her colours. So, this is how I do it. What is A? A is these 3. Okay, what is B? Here. What is not C? Okay, where do they all intersect? It means I need 1 of each colour in the same section. 0. So the answer is 0, because if you have a look, the only section that has pink, green and blue. Yeah, because we're looking at intersections. Guys, I'm going to do the same again. Now this time, luckily I already did it. So it's A, union B, union C dash. Okay, everything but 7 is coloured in. The union, it doesn't matter if they have mixed dots or whatever. So everything but 7. How many did I have in total? So what's 120 take away 7? This is 113 over 120. Okay. Next, it says find the probability that the shoe has at most 1 type of defect. What does that mean? Oh no. Guys, for some reason, my rubber stopped working. Okay, we'll forget about this. So what does it mean, at most, 1 type of defect? Either 0 or 1. Okay? So that means we've got to do 7 plus 1 plus 9 plus 93. Yeah? So what do we get? 110? Out of 120. Given the selected shoe has at most 1 type of defect, right, guys, this is really important. Given that it already has at most 1 type of defect, my denominator changes. We're no longer out of the total. What are we out of now? 110. Okay, it's pretty simple. It says given that it already has 1 defect. We already know that the probability of getting a defect, most one is 110. So given that it already has this, so now we're out of 110, yeah? There's already these people. Find the probability that it has a defect in stitching. So how many we got stitching? 9? Yeah? Brilliant. Okay. The random variable x is the number of events A, B, and C that occur for a randomly selected shoe. Find E of x. Okay? Okay, so now I need to find expected. Okay? So let's think about this. So we need to look at what? X. What's the probability that we have 0 defects, 1 defect, 2 defects, 3 defects? Can we get 4? No, don't be ridiculous. So now we're looking at the probability of x equaling x. So what's the probability of 0 defects? We already did this. 93 over 120. How about 1 defect? So we're going to have 7 plus 9 plus 1. 17 out of 120. How about 2 defects? 0, 3, 5. 8. 3 defects? 2. What should they all add up to? 120. Yeah? Over 120, which we know is a whole one. Now, how do we find E of x? What is E of x? It's like the mean, really, isn't it? Yeah? So you're going to do 0 times 93 plus 1 times 17 over 120 plus 2 times plus 3 times. What do we get? 6 plus 17. 39 over 120, which we can simplify to 13 over 40. Okay, so the first question, apart from F and maybe a little bit of E, is actually all GCSE. Okay, great work. Okay, question 2. Tom's car holds 50 litres of petrol when it's full. Okay, so we know that pretty much the maximum is going to be 50, right? For each of 10 journeys, each starting with 50 litres of petrol in the tank, Tom records the distance travelled in kilometres and the amount of petrol used. The summary statistics for the 10 journeys, it keeps saying 10. What do we think 10 is? N. You know that N is 10. Calculate the product moment correlation coefficient. Right, we're going to go straight to our, what's it called? Formula book. Okay, we're going to go to S1. It literally gives us correlation and regression. Product moment correlation coefficient is R. Okay, so R equals, now we have SXY over the square root of SXX SYY. Okay, what do I have? I have SDD and SPP. Okay, what do I need? Yeah, SDB. So, SDB, how am I going to work that out? I need the sum of XY. Do I have the sum of XY? Yes? 5,240.8 minus the sum of X times the sum of Y divided by N, which is 10. Okay, so this is going to give me 13.48, etc. Right? So now, how do I find my R? I'm going to substitute in 13.48 over the square root of 344.9 multiplied by 0.576. Okay, this is going to give me 0.056. Okay, full marks for that. Wasn't that easy? And again, when I keep talking about this, it's just about being able to read. Can you read? Yeah? You can get full marks on this question then. Right, next. The amount of petrol remaining in the fuel tank for each journey, W litres, is recorded. Write down an equation for W in terms of P. Well, first of all, is this 2 marks? Oh no, just part I. God, that's simple. So, what does it mean? Write down an equation in terms of W, in terms of P. W is what's left. P is what we've used. So, how much do we have in the beginning of every journey? 50. Told us that. And then we're going to use P. So what's left? Of course, it's 50 minus P. So then it says, hence write down the value of the product moment correlation coefficient between W and P. Okay, so for the second part, it's like, because they're completely inversely proportional, okay, as one goes down, so does the other. It's like we're looking technically at the gradient, okay? So the value of the product moment correlation coefficient between W and P is -1, okay? It's like the gradient of P, yeah? Perfect. Now it says, write down the value of the product moment correlation coefficient between D and W. So if we know what the correlation coefficient between D and P is, well, between D and W, all we have to do is multiply by the other correlation coefficient. So we have 0.956. We're going to multiply that by -1 to get -0.956. Okay, because we know it's inversely proportional. Okay, and then what you don't realize as well is technically what we're doing now is looking at coded data. W equals 50 minus P. And remember, when we're looking at the R value, we only take in consideration the multiples. Yeah, we don't worry about the 50. Okay, so that's how it affects it. Okay, question 3. So let's have a look at question 3. The stem and leaf diagram shows the number of deliveries made by Pat each day, where A, B, and C are positive integers, A being less than B less than C. An outlier is defined as any value greater than 1.5 times the interquartile range above the upper quartile. Given that there is only one outlier for these data, show that C equals 9. Okay, so first of all, the interquartile range. How are we going to find this? Okay, so I just go old-fashioned. I just start crossing stuff off. 2, 3, 4, 5, 7, 8, 9, 10, 11. Okay, so where is my median? What is it? Okay, a median is in between these two. Is that right? Yeah. So now to find the lower quartile, I just need to do the same again. 1, 2, 3, 4, 5. Okay, so I get 116. And then, because I find the median first and then I go for the lower quartile. I'll just do the median of the median, like the median of the lower end. It depends how you like to do it. I mean, personally, I forgot that one. Personally, I just prefer the colors. Okay, so I'm going to get 116 and 125. So 125 minus 116, what do we get? 9. Okay, so this is the interquartile range. Now remember, in stats, it's really good to label everything as in, like, don't just leave it at 9. Write down that IQR equals 9, yeah? You know what that means then. So an outlier is defined as any value greater than 1.5 times the interquartile range above the upper quartile. So if I do 1.5 times 9, what do I get? 13.5. Okay, what's my upper quartile? Pardon? Yeah, 125. If I add my 13.5, what do I get? 138.5. Okay, so that means any number greater than this is an outlier. So it says there's only one outlier for this data set. Okay, only one outlier for this data set, and we need to show that then C equals 9. So what's the greatest value technically C could be? 139. It has, like, this is like the greatest value. C has got to be less than or equal to 139 or greater than 138.5. Technically, we can't have 0.5 of a delivery, can we? Yeah? So what does C have to be then? Yeah. Therefore, C equals 9. Okay, so this has to be 9. I don't understand why I can't rub out. Okay, so C is now 9. We've showed it. What does A and B have to be? Remember, A and B, 130, but less than 138.5. Okay? So, I mean, we might not need that yet, but it's just a fun fact. Right, the number of deliveries made by Pat each day is represented by D. The data in the stem and leaf diagram is coded using x equals d minus 125, and the following summary statistics are obtained. Find the mean number of deliveries. Okay, how do I find the mean? How do I find the mean? Yeah, so the mean number of deliveries is going to be the sum of x divided by n. So I'm going to have minus 96 divided by how many deliveries? 24. Okay, so then what are we going to get? Minus 4? Okay, now remember, guys, first of all, we don't have a negative number mean deliveries, okay? So you need to be using your head here, right? And if you've just put minus 4, you're a fool, okay? The mean number is going to be in between these values, right? So even if you're not sure how to do the coded, you know we found the mean of x, but actually it gives it, we need to find the mean using the coded data. So what am I going to do? This basically means the mean of x equals the mean of d minus 125. So minus 4 equals the mean of d minus 125. So what am I going to do to both sides? Add 125. So what do I get? 121 is the mean of our coded data. Okay, so we get 121 is the mean number of deliveries. If you have just put minus 4, I mean, you don't even have to understand what's going on here to just realise, well, that's not right. We're not going to have a negative number of deliveries, are we? Let's be realistic, yeah? Always think back to the context of the question. Okay, it now wants us to find the standard deviation. So, what is the standard deviation? How do I find that? What's the formula for standard deviation? Do we need to know this? Yeah, we do need to know this. What is it then? Square root of Sum of x squared over n minus the sum of n all over squared. Okay? So obviously we don't have the sum of x squared. So however, we do know that this is the same as the sum of x minus the mean of x all squared, then divided by n. Okay? So what we're going to get, the square root of 1306 divided by 24, which is the square root of 54.4, which equals 7.38. Now, why haven't I had to change anything here with the coded? Standard deviation isn't affected by adding or taking away. Okay? It's only if we multiply or divide. Yeah? So, this is absolutely perfect. Brilliant. So, one of these 24 days is selected at random. The random variable D represents the number of deliveries made by Pat on this day. The random variable X equals D minus 125. Find the probability of D being greater than 118, given that X is less than 0. Guys, does everyone know what this line means? Yeah? Given. Yeah? Okay, so let's do some... so this is the same as saying, find the probability of D being greater than 118. Now, what do we know about X? It's this. So then we're saying, literally, given that D minus 125 is less than 0. Okay, so it's straight out substitution. So, what does this mean? It's the same as saying, what's the probability of D being greater than 118 and D being less than, given that D is less than 125. Now, it's really simple. It's literally just a case of counting. What is the probability of D being greater than 118? I'm literally just going to go up. Okay, so I like to do the given bit first. So what's the probability that D is less than 1.25? So where's 1, 2, not 1. Here's 125. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So it's out of 14. And so given that it's this, what is D greater than 118? So where's 118? Here. So how many do we have? 1, 2, 3, 4, 5. Perfect. We can literally just do counting. Okay? Beautiful. 5 out of 14. Okay, question 4. The random variable W has a discrete uniform distribution. Okay, what does this mean if we're looking at discrete uniforms? Yeah, they're all the same probability. So, if W equals a fifth for this, find the probability of W being between 2 and 3.5. So, first of all, let's draw a lovely table. Because we like lovely. Oh my. We love lovely tables. So, for W, and when the probability of W equals W, we now have 1, 2, 3, 4, 5. So if the probabilities are all the same, you tell me. Right? If we've got 5, clearly they're all 1 out of 5, yeah? So, now it wants the probability of 2 being less than or equal to W being less than 3.5. Now, being less than 3.5 is technically only 3, isn't it? And 2 and 1. But then we've got to be greater than or equal to 2. So it was just a fifth plus a fifth, which is going to be 2 fifths. Okay, nice and easy, 1 mark. Right. It says the discrete random variable X equals 5 minus 2W. So what do we have here? A bit of coding, don't we? Yeah? So it wants us now to find EX.
So to find EX, what do we do? EX equals 5 minus 2 lots of EW. Okay? What is EW? Free. Were you yawning as you said that? Came out a bit strong. Right then. So, how do we know it's free? Because it's the sum of 1 times this, plus 2 times this, plus 3 times this, plus 4 times this, plus 5 times this, which is free. So we're going to have 5 minus 2 lots of free, which equals -1. Perfect. Now it says find the probability of X being less than W. Okay? Now they've already told us what X is. So this is the probability of, instead of writing X, what could I write? 5 minus 2W. It says it in the question. Can you read? Miss, it's all about reading in this class. So can you read? I'll show. Okay, so 3 came from this. 1 times 1 over 5 plus 2 times 2 over 5. So this times this times this, plus 3 times 1 over 5, plus 4 times 1 over 5, plus 5 times 1 over 5, yeah? I did this times this, plus this times this, this times this, this times this, this times this. Happy? Okay, so let's go back to this. So if you can read, literally, it's about spotting. Okay, we know X equals this. We're going to get the probability of, instead of writing X, I'm going to write 5 minus 2W less than W. Okay? Which equals the probability of 5 less than, if we add 2W to both sides, 3W. Which equals the probability of 5 over 3 being less than W, which we could write as, what's the probability of W being greater than 5 over 3? What even is 5 over 3? 1.66, right? So if I think about where's 1.66, it's roughly here. What's the probability of it being greater? We have 1, 2, 3, 4. So we add up the probabilities, we're going to get 4/5. Perfect. Okay, let's go to pink. Right, the discrete random variable y equals 1 over w, okay? Find the probability distribution of y. So, it's a discrete random variable, so what do we know? Guys? Yeah, they're all the same. So let's do this. So y. And then we're going to have the probability of y equals y. So what is y? 1 over w. What was w on the first one? 1. So I just get 1 over 1. Okay, what was w of the second one? 2. So 1 over 2. Everyone get it? Yes. 1 over 3. 1 over 4. 1 over 5. What do we know about the probabilities though? It's still all a fifth. Why? Because it is discrete random variable. Absolutely. So, now we've done this, the probability distribution of y. Check. Now it wants the variance of y. So var y. How do I find this? Is there a formula? Yeah, there is. So, we're going to have e of y squared minus e of y all squared. Okay? So how do we find this out? Okay, so how do we find e of y? Yeah? So for e of y squared, I'm going to do, what is my first value of y? 1. So I'm going to do 1 squared times my probability plus the next value of y squared times my probability plus the next value of y squared times my probability. Basically, they're all multiplied by 1/5. Plus my next value of y squared times probability plus the next value of y squared times probability, okay? If I do all of that, I get 5269 over 18,000. Perfect. Now, how do I find E of y? Just like we did earlier, so I'm going to do 1 times a fifth, plus a half times a fifth, plus a third times a fifth, plus a quarter times a fifth, plus a fifth times a fifth. This is going to give me 137 over 300. So now the variance of y equals 5269 over 18,000 minus 137 over 300 squared. It's going to give me 947 over 11,250, which is approximately 0.0842. Okay? It says show your working. I have shown my working. Now, next step, it says find the variance of 2 minus 3y. Okay? So, what do we know about 2 minus 3y? If we're looking at variance, what are we actually... Does the 2 matter? No, it's just the minus 3. It's because that's what we're multiplying by, right? So what am I going to do? I'm going to square the minus 3. So... minus 3 squared times 947 multiplied by our own variance, okay? What do we get? 0.7576. Beautiful. Okay, so Gia writes a computer program that randomly generates values from a normal distribution. He sets the mean as 40 and the standard deviation as 2.4, okay? So, what do we know? Okay, so straight away, I know that the normal distribution is 40, and then what do we always write here? We always write the mean squared, don't we? Yeah? It's really important that we write this down. And it wants us to find the probability that a particular value generated by the computer program is less than 37. So we want the probability of x being less than 37. So, how do we work this out? Well, it's really simple. We need to find our z value. So this is the probability of z being less than what we want minus our standard deviation divided by the mean, okay? So, what are we going to get? The probability of z being less than 1.25, and this is a negative, okay? What does that actually mean then? Like, if I was to draw this,
We still have to go on, like, we'll turn it into a positive.
okay?
We'll take
So,
0.894.
where is minus 1.25?
0.894
So where is minus 1.25? Should we say here? Yeah? Can we find that?
Yeah, it's 1 minus 0.894.
Okay, minus 1.25, we could flip it, right? So we're going to find the positive of 1.25. Okay? If we find the positive, it's actually, remember, whenever we use the z values, it always finds us the probability of z being less than a number. So we're going to actually get this bit, but what we want is this tiny blue bit. This is why we do 1 minus. So if we find the probability of z being less than 1.25, but we do 1 minus it, this is the exact same, okay? So using the table, 1 minus, I'm literally going to use the table to find 1.25. Okay, so I've just taken this picture from the table. 1.25 reads at 0.8944, which is going to give me 0.1056. Okay, nice and easy, 3 marks, isn't it? Okay, brilliant. Next, Gia changes the mean to m but leaves the standard deviation as 2.4. The computer program then randomly generates 2 independent values from this normal distribution. The probability that both of these values are greater than 32 is 0.16. Find the value of m, giving your answer to 2 decimal places. Right, so the probability of x being greater than 32. Okay? Now, so because it generates 2 values, this squared equals 0.16. So that means the probability of x being greater than 30. Okay, so this is going to give me 0.4. We don't have a negative probability. So now, what do we know? We know that this time our standard deviation is 2.4, but our mean is m. So we're going to have x to the normal distribution of m and what? 2.4. Okay, this is still the same. So now we're going to have the probability of z being less than 32 minus m over 2.4. What does this actually equal? 0.4. So what do I do now? I use my what? Anybody know? Okay, so where is 0.4? Here? Yeah? Okay. But what does the z value give me?
Miss, why did you change the sign for z is less than
Sorry guys, I didn't mean to change the sign, I was just looking at the question before. Okay, so z is greater than 32 minus m.
Yes.
So we want up here. Okay. How am I going to find what this value is? Okay, so we can see on the second table, this is what we have. So that means our z value is 0.2533. Now, if we equate this to 32 minus m over 2.4, multiply both sides by 2.4, going to get 32 minus m equals 0.60792. Then, what am I going to do? I'm going to take away 32 from both sides and multiply by -1. So then I get m equals 31.39, etc. Beautiful. Okay. Gia now changes the standard deviation to 8 and the mean to 4. Okay? So what does that mean? Okay, so it wants us to find the probability that at least one of these values is negative. So we want the probability of x being less than 0. So this is going to be the probability of z being less than 0 minus 4 divided by 8, which is the probability of z being less than a half. Okay?
Minus a half.
minus a half. Sorry. Which is the probability of... Okay, no. Probability of Z being less than minus a half. So we want this part here. So what are we going to do? 1 minus the probability of Z being greater than a half? No. Less than positive a half. Okay, so we're also looking for the probability of it being negative is the same as 1 minus the probability of positive, 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 right? So we already know it's Z 1 minus, so right, let's do this one. What is the probability of Z being less than a half? Where is this? 0.6.
0.69.
So from the table, 0.6915, okay? So 1 minus 0.6915, and then we have it to the power of 5. This is going to give me 0.842. So I changed it from a negative to a positive because I can't find the negative on the Z table. Z table is only giving me positive values. So I've done 1 minus of the positive. This goes from here to here. There. So how do you get rid of this negative? You do 1 minus of the positive. It's the same because it's symmetrical.
But wouldn't that be Z is greater than a half?
Yeah, that's why it is 1 minus.
That's why we're doing the 1 minus. Okay? Right, perfect. Okay, question 6. Students on a psychology course were given a pre-test at the start of the course and a final exam at the end of the course. The teacher recorded the number of marks achieved on the pre-test P and the number of marks achieved on the final exam F for 34 students. Okay, first of all, what does 34 mean? Yeah, let's write that down, okay? We've got a lot of words, and also, if we just look down at the marks on this first page, 2, 3, 4, it's only 5 marks. It's going to take us 5 minutes to read what's happening. Okay, so it's really good to write things down. What was P? Pre-test, yeah? So literally, on here, I want you to write down P pre-test, F after test, and final exam, exactly. So, we're going to write down N equals 34, P, pre-test, F, final test. Now, the reason why we're going to write this is obviously it's going to help with the context of the question, especially with the wordy ones, right? It then says, the equation of the least squares regression line for this data set can be found. Now, what do I know? What do I know, guys?
P equals 62.4.
P equals 62.4 on the pre-test. Okay, so for the students, the mean number of marks is 62.4. Use a regression model to find the mean number of marks in the exam. So literally, what does that mean? I'm going to do F equals 10.8 plus 0.748 multiplied by 62.4. Okay? What does that give me? 57.4752. Okay, now it hasn't actually told us anything, really. But they've done 1 decimal place on the other one, right? So we could just say this is approximately 57.5. So we can do 1 decimal place on this one. Okay, give an interpretation of the gradient of the regression line. Now, the gradient of the regression line is, we have to actually be a bit more specific here. What does a gradient mean? Okay, what does gradient mean? Do you remember back in primary, it was like for every 1 along, you go up? Yeah? This is technically what's happening here, okay? So, as the final, no. Right, so are we ready? So let's go with the one along. So as the pre-test mark increases by 1, the final test mark increases by 0.748. This is technically what's happening here. Okay? Now in the what's it called, mark scheme, it says, so in the mark scheme it's really clear. You have to mention pre-test, final test. You have to mention as one increases, the other one will increase by 0.748. Basically, what I've written is one of the most perfect statements here. Okay? The statement given in the mark scheme is, for each additional mark scored on the pre-test, the average mark on the final exam increases by 0.748. Okay? Okay, part C. It says, consider the equation in the regression line. Priya says that she would expect someone who scored 0 marks on the pretest to score 10.8 marks on the final exam. Comment on the reliability of Priya's statement. First of all, do we have any data with 0? No. Okay, so is it reliable? It's unreliable. Okay, and then we're going to use that big word again. What is it? Extrapolation, okay? It's unreliable, and this is because, right, there is no data for, and if we have a look, where's the smallest amount of data? It's about here, yeah? Is that 19? There's no data for less than 19 on the pretest. Okay, and then you can write in brackets extrapolation. I hope I've spelled that right. Okay, perfect. Now, last bit, it says write down the number of marks achieved on the final exam for the student who exceeded the expectation of the regression model by the largest number of marks. Okay, so first of all, what does this mean? If we're looking at someone who exceeded the expectation of the regression model, when we think about the regression model, it looks at the least squares, okay? So you can see, like, this is perfect. Here, can you see it's like small, etc. So what we're looking for now, if it exceeded the expectation of the model, we're looking for the data point which is furthest away from the line, okay? Now, this point is in fact the furthest away from the line, if you have a look, okay? If you were to get a ruler out, can you see this ruler on there?
No.
Oh, but you can see on my,
I don't know. Yeah.
no, but you can see it right now. I mean, stand up.
Yeah.
Yeah. Okay, if we were to measure this with a ruler, this is 1, 2, 3. This is 3. If you then look at this compared to all the other points, we're not really going to find any, okay? No. Okay, so you have to kind of guess a little bit with your eye, but then maybe do some measuring. This is the furthest away. This length here is the furthest away. Also, if you think about it, this person's a bit of an anomaly in terms of we've got quite a low score here, but actually, if you think 60, if we were to put this into the regression line, if you did 10.8 plus 0.748 lots of 60, what do we get? Okay, you'd expect 55.68. However, you can clearly see that what do we get here? 76, okay? So, write down the number of marks achieved on the final exam for a student who exceeded the expectation of the regression model by the largest number of marks. It is 76 marks is the answer. However, this one, I mean, it is down to interpretation, but technically it's not, because it's the one that's the furthest away, okay? Okay, the question's not finished there, right? There's another part. Okay, here's the second part. It's like deja vu. Right, find the range of values of P for which the regression model predicts a greater number of marks on the final exam than on the pre-test. Okay.
Because it times every time for WP. And you add that one.
So we want to know when is F greater than P. Yeah? When are the final marks greater than P? But we already know what F is in terms of P, don't we? So when is 10.8 plus 0.748P, when is this greater than P? So all we're doing here is substitution. This makes a lot more sense. So this is when is 10.8 greater than 0.252P, which is when is 42.86 greater than P. So P must be less than 42.86. Yeah? Perfect. Okay, later the teacher discovers an error in the recorded data. The student who achieved a score of 98 on the pre-test scored 92 and not 29 on the final exam. Didn't they have a question like this the other day? Am I making that up?
Well, we did this in class the other day.
Oh, right. A score of 98 on the pre-test, so they actually scored 29 and not 92. The summary statistics used for the model are corrected to include this information, and a new least squares regression line is found. Yeah, we did a question like this the other day.
It was this question.
Ah. So, this was the original, right? The original was... Okay, so with this one, sorry, it's supposed to be... So this is for the final exam, right? So this means it's our sum of P is different. Now, for the regression line... What do we need? Okay. Calculate the gradient of the new regression line. So the gradient of the new regression line is B. Now B is formed by doing SXY over SXX. Okay. So B, SXY in our case is SPF. Sun cream. Right, over SPP. Now, because they're saying that this is our final one, it's only anything with an F in is affected, right? So, is SPP affected? No, we can keep that as it is. That's just like, great, we know what that is. However, SPF, is that affected? Yes. Now, let's have a look. How do we work out SPF? So, SPF is worked out by doing the sum of PF minus the sum of P times the sum of F over N, okay? Now, they never even gave us an FP. They've given us the old SPF, but they haven't actually given us anything. Okay, what do we know that's changed so far? So, we know, how do I get from 29 to 92? What did I add? 63?
Yeah.
Okay, so there's a difference of 63. Okay, so we need to add 63 onto a few different things. So let's see what's happened. We know so far, so it's literally a case of working backwards. What is SPF? 11648.35. This equals what? The sum of PF, which is 133486, minus, what's the sum of P?
2120. Oh, yeah.
2120 times the sum of F. Now, they didn't give us a sum of F, did they? So we need to find that. All over 34. Okay, now remember this is the sum of F, the previous sum of F. Okay, so I'm literally just going to use my calculator to find F. Okay, so obviously I minused this from both sides, multiplied by 34, then divided by negative this. Okay, everyone should just be happy doing this. So therefore, the sum of f equals 1954.00 something. Okay, we should all be happy with this. Now, technically, if something increased from 29 to 92, I need to add 63 to get my new sum of f, right? So plus 63. So my new sum of f is in fact 2017. Perfect. Yeah. Okay, 2017. So now we have my sum of f. So now, what else do I need to work out? The sum of SPF.
No, the sum of PF.
The sum, right. So the sum of P times F is what?
2120 times 2017.
Is
4276040.
right. So the old sum of PF. I'm going back to pink. Right. The old sum of PF equals 133,486. Now, in that, somewhere, we know that that's going to be 98 times 29. There's a 98 times 29 in there. So technically, we have to add on 98 times 63. Yeah? Because the score changed from 29 to 92. So my new sum of PF equals 133,486 plus 98 times 63, which is going to give me 139,723. Right, I'm not listening to you again. What's happening here? Right. It says 98, not 99. Right. 139,660. Okay, perfect. So this is my new sum of PF. So how do I find? Right. SPF. What does SPF equal? So the sum, my new sum of PF, which is 139,660, minus the mean 2120 times our new mean 2017 over 34. This is our new SPF.
That equals 13,894.
13,894.11.
Ooh, I've got discrepancies here. 94.117. So now our new gradient is SPF 13894.117 over SPP. Now, did our SPP change? No. So 15,573.76. What do we get?
0.892.
89.
0.892.
2. I had so many different accents and I was so confused between 2 and 3. Okay, perfect. Is there anything else I need to do? No? Brilliant, that's it. Okay, this, to be honest with you, I didn't think, I wouldn't really call this part statistics. First of all, we were given a formula. This was literally just rearranging formulas and thinking. Okay, well done. Question 7. A bag contains n marbles, of which 7 are green. From the bag, 3 marbles are selected at random. The random variable x represents the number of green marbles selected. The commutative distribution of x is given. Show that n minus 1, n minus 2 equals 7,980. Okay, so what's actually happening here? Okay, so let's think about this. If 7 are green, okay, going to have 7 over n. If we take a marble out, and we're still green, right? What's happening? 6 over n minus 1, absolutely. We take another marble out. 5 over n minus 2. Okay, this is like GCSE level still. right?
Yes.
Yeah? So, however though, what should this equal and how are we going to multiply? Because remember, we need to get the 7, 9, 80. But what do we know? Yeah, we know the probability of x equaling 3 equals 1. So what does that mean?
You have to find the probability of x equals 3.
It's a cumulative.
Yeah, of course it's commutative. So where do we go from here? So 1 minus 37 over 38 equals 1 over 38. So what does that mean? The probability of getting green, green, green is 1 over 38. Perfect. Well done. So now we're going to cross multiply. So we're going to get 38 lots of 7 times 6 times 5 equals n lots of n minus 1, n minus 2. And lo and behold, if you put this in your calculator, what do you think we're going to get? 7,980. Absolutely. Okay, brilliant. It says verify that n equals 21 satisfies the equation in part A. We're just going to substitute it in, right? So we're going to get 21 lots of 21 minus 1 lots of 21 minus 3. Where did 3 come from? It's 2. Okay, what does that equal? 7,980, therefore verified or proved. Okay. Right. Next up, it says find the exact value of A and the exact value of B. So, how are we going to do that? We know the probability of green, green, green is 1 over 38. So what's the probability of no greens? Okay, how are we going to do that? Are we still using n? So what do we know? Okay, so because we're using 21, what's the probability of picking not green? Okay, we know it's out of 21. 7 is green, so what's not green? 14. Yeah? Okay, then what's the probability I pick not green again? 13 over 20. What's the probability I pick not green again? 12 over 19. This is going to give me 26 over 95. So that means A is 26 over 95. Now, what do I know about the next one? Did we work out what the probability of 2 was exactly? No. Okay, so what do we know? How are we going to do this? We know the probability of x equals 1 is probability of x equals 0. Well, sorry, f of x equals 1 is the probability of x equals 0 plus the probability of x equals 1. So, we know that b equals 26 over 95 plus the probability of x equals 1. How could we get 1 green? Let's face it. We could have green, not green, not green, not green, 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 not green, or not green, not green, green. No other possible ways, right? So, if you think about it, if you wanted to, we could do like a probability tree visually. Okay? We don't have to fill everything in, but we can think about it. So what's the probability of getting a green? We know that our denominators are going to change each time. Okay? We know that. So for each one, we can already establish the denominators because we're taking one, we're not replacing it. So for the first one, remember we always start with 7 green, 14 not green. So 7 over 21 is green. How many are left? 14, 13. Perfect. Not green, we start with 14, 7, 13. You're going to find that they're all the same. We're just going to multiply it by 3. Probabilities stay the same here. 14, 13, 7. Okay? So, what do we have? 91 over 190. So what do we know B is? 20 plus 26 over 95, because we've just worked out what x equals 1. So that means B is 143 over 190. Beautifully done. Okay? What's the difference with this and a GCSE question? It's just the frequency bit here. That is literally it. Okay? Well done.